Now we'll consider what are called colligative properties. And these are very interesting properties based on the concentration of solids in a solution. So an example of a colligative property is the freezing point, lowering, if we dissolve something in water, it will lower the freezing point of water. Another example is the boiling point elevation. So if we dissolve a solute in water, it will raise its boiling point. A third example of a colligative property is called the osmotic pressure. Now let's consider these three in turn. For the first two, the freezing point depression and boiling point elevation, there are simple formulas to express the change in the freezing point or boiling point. So they are the change in the temperature for that phase is equal to the molality of the solution times a constant, which we will say is the freezing point constant or a boiling point constant. So we have the change in the freezing point. It's equal to the molality times the freezing point constant. That's this equation. Or the change in the boiling point is equal to the molality times the boiling point concentration. These are for ideal solutions. If we have a very concentrated solution, then this relationship is not linear, or a 1-to-1 ratio with the change in the temperature with the molality of the species, and so we introduced what we call a Van Hoff factor, which is basically a fudge factor. So in this case, the change in the temperature for the phase is equal to I, the Van Hoff factor, times the molality times, say, the freezing point depression or boiling point, this is B, constant. If it's not specified, then we assume that the Van Hoff factor is equal to 1. Now remember, this delta T is the change in the temperature of a particular phase change, either the boiling point or melting point. And the sign, delta T, is always positive. So if the freezing point is depressed, delta T is still positive, but the freezing point is reduced by that much. So say delta T for the freezing point is equal to 5 degrees centigrade. For water, the freezing point of that solution is going to be negative 5 degrees centigrade because it's reduced by the amount delta T. On the other hand, if delta T boiling point is equal to 5 degrees centigrade, then the boiling point of that solution will be 105 degrees centigrade because it's the boiling point elevation. So we need to remember freezing point depression, boiling point elevation for delta T.